Hi, everybody. Welcome to week 3. I just finished grading your labs from last week, cones 3 and 4, and they looked really, really good. So I know I said that the ggplot 2 cone would be a little challenging, and I don't think that it was for you all, which is fantastic. I think the multiple media, having an interactive assignment and a video and some reading, I think it's working. So I was really, really happy with that. You guys are putting in the effort, and I'm very happy with it. So the ggplot 2 cone was supposed to be a little challenging. You all sailed through it, which is fantastic. These cones, I think, will actually be challenging. So get started on it early. I know I'm not uploading this until pretty late, and I'm sorry about that, but come to office hours for help with these if you need it. So I just wanted to talk about something very quick about programming first, and then I'll go over the cones, and hopefully this video is not too long. So what I wanted to say, I think a couple of people are struggling with this, and you may be struggling with it and not even knowing that you're struggling with it, but what gets quotes and what doesn't get quotes when you're programming. So what gets quotes is character strings. So character strings. So for instance, in cone 1, we had a character vector, apple, banana, economics. When the thing that you're talking about is literally the string of characters, A, P, P, L, E, then that needs quotes around it. So the quotes are always going to be character strings. Versus no quotes, that's always going to be a variable. So for instance, something like, we can do variable assignment. So last week in the Tibble cone and in the ggplot 2 one, we had a variable that we used for our data set. So you had like students, and then we had a Tibble, or we had like student sample A, and then we put our data in that Tibble, and then we could pipe the name students into ggplot 2, whatever, because that referred to our data set. It was a variable that referred to our data set. So it could be a Tibble, could be a data set. It could also just be, let me just do for a little example here. Let's have a variable named x, and let's make it refer to the number 3. And I'm going to run this line of code, and keep an eye on the upper right-hand corner. You're going to see my environment's empty right now, but I'm going to run this piece of code, and ta-da! Now I have a variable called x, and it refers to the number 3. So, or you could have a variable called y refer to the vector 1 to 3. It's an integer vector, and then I can say x in my console, and it'll print 3, or x plus 1, and it'll print 4, or x times 10, it'll print 30, or I could do the same with y. So y is the vector 1 to 3. I can say y plus 1, that'll be the vector 2 to 4, 2, 3, 4. So variables can be values, they can be vectors, they can be data sets, they can also be functions. So we had what are functions that we've learned? The function Tibble, and you can call a function when you say its name, and then you have like the open and close parentheses, and you have arguments inside of there. But if you just say the name of the function, that's actually a variable that refers to that function. And you can kind of see, if you just run the name Tibble, you can see, yeah, it's a function, and this is its definition there. So functions, so I think that's the basics. If it's quotes, it's a character string. And so you can see, X in quotes, that's no longer going to refer to 3. That's going to refer to just the character X, right? So if we run that line of code, it just comes out X. Or if we say Tibble in quotes, that's going to be the character string Tibble. So I think that was all I wanted to say about that. Let me know if you have more questions about that, but hopefully that helps kind of build some intuition about when to put quotes in and when not to. And you can see in Cone 5, I load the same dataset students as you worked with in Cone 4. And you can see, let's run all this code to bring the dataset students in there. And then I can say the name students, not in quotes because it's a variable that refers to our data set. And the column names, so I can say, when we were doing ggplot2, you're saying students, pipe that into ggplot, and then you have an aesthetic mapping. Say I want grade 1 to be on the x-axis. So x equals grade 1. And notice grade 1 does not have quotes around it because grade 1 is a variable. Remember how columns are variables in a tibble? Grade 1 is a variable inside of this tibble. So that's why, I wanted to emphasize that. But like female here, or 5 to 10 and like less than 2, no, yes, are they're character strings. And this line here tells you kind of the data type. So the CHR is for character. That's a character string. So variables can take on values, right? And the variable sex can either be female or male, and those are character strings. Or, so the data types that we have here, some are character strings like sex and romantic, and some are, the DBL stands for double, which is a number. It just means that it's not an integer. It's a double precision number, so it can take like decimals. And then the third type is a factor here, which is what I've done with these lines of code. You're going to learn what mutate does in the cones today. And what I've done here is, so a factor is very similar to a character string, except there are levels. Because I wanted, when we plotted these variables, I wanted it to always order, for instance, alcohol, in this specific order. I didn't want it all jumbled around because it would be hard to visualize. So I always wanted, whenever you plotted alcohol, I wanted it to go from very low to moderately low to medium to moderately high, etc. So that's why I had this little transformation in there to make these variables into factors so they could have that order. All right. I think that was even more than I planned to say, but let's go on to, let me know if you have questions about this stuff, and let's go on to the lab. So here's lab 3. And scrolling down to the reading, I'll just kind of go over very quickly what I was trying to do with the reading here. This, I give a little bit of explanation about this package called dplyr. The name is supposed to evoke data pliers because dplyr helps you manipulate your data. I explain here, I don't love that because as a beginner, you're like, why would I want to manipulate my data? I don't understand. But I think what I always think of is when I have a question about my data, I always know I got to reach for dplyr. So dplyr is about making queries for your data, just like with SQL. So in this reading, what I'm trying to do is show you that when you're learning dplyr, you're also learning SQL. SQL is a fairly old programming language that's used for interacting with databases. So it's very, very useful because it's something that's used in industry everywhere. So useful to learn, and the nice thing about it to learn is you can do it with a couple of cones in a single night, because it's basically 7 main functions. And dplyr it's a little bit of a simplification in some ways. SQL stands for Structured Query Language. So query is right in the term there. And dplyr is a query language. It doesn't have to be so structured. You can call those functions in any way, in any order that makes sense to you. But so I have a little page for each of the 7 functions. The first cone, you're going to learn just 2 of them, and then you're going to practice that. The second cone, we're going to add 3 more, and then the final cone, we're going to talk about the last 2. During the first cone, you're going to just learn select and filter. I'm going to zoom in here a little bit. But I give you select. I give you a little description about what select does. What it does is it just pares down the columns. So sometimes you get a data set and it has 50 variables in it, and it's just way too big. You're not interested in using all those 50 variables. You're interested in using 3 of them. So you would select just the 3 that you want. And then in this little 2x2 grid, I made this lower left-hand corner highlighted, because that's kind of the important thing to focus on in these cones. I want to tell you about how SQL also works and how it's basically a one-to-one mapping between dplyr and SQL. But we're not going to do any SQL in this cone. I just wanted to show you because it's kind of fun and interesting, I think. So I have the example here. Here's how you would just select these columns to pare down your data set. And now after running these lines of code, that would output this smaller data set. So it just grabs those 3 columns that you want. Now you have a nice smaller data set to work with. And this is how you do it in SQL. You can say select just these columns from the data set. So SQL also has a function called select, and it does the same thing. Then next comes filter. So while select is about selecting the columns, filter is about selecting the rows based on logical conditions. So I say, for example, to query for only the female students, you can see here I've just highlighted all of the female students, and if you want to output a tibble just with the female students, you would filter on the variable sex is equal to the character string female. And you can filter on any logical condition. And SQL doesn't have something called filter. The thing that filters your data in SQL is called where. And so you'd say where sex equals female. But remember, in R, the logical operator that's relevant is the double equal sign for is equal to. So that's filter. So then you'll take, then I have a bunch of logical operators in R, and you can use these to form logical conditions, and you can, query your data by filtering on those logical conditions. So R has is equal to, like we just saw. It has greater than, less than, greater than or equal to, less than or equal to. It has and, so if you want to string together multiple logical conditions, you could do that with an and, or you could do it with a comma. Commas become ands for the filter. Yeah, I explain that more in the cone. If you want or instead of and, you can use the horizontal line thing. We also have an in. So you would say a variable like study time is in a character vector. It's one of the elements of this vector. And then the last one is the exclamation point reads as not. So you can say, I want where study time is not in this character vector. That's how you do that. So then I prompt you to go and work on the fifth cone to practice select and filter. And then, so I'll just kind of quickly go through the rest of the functions, and then you'll have kind of a overview of it. The next dplyr verb that we'll learn is arrange. So you can say, I want to arrange students from highest grade to lowest grade. And then you would say, take your students, arrange by descending final grade. And then you can see I've kind of highlighted things. Like the green is the highest grade, and then it's like yellow, and the red to the lowest grades. So running this line of code just sorts the observations and puts the person with the highest grade at the top and sorts them all the way to the lowest grade. So that's what happens if you sort descending by final grade. In SQL, there's an order by function that does the same thing. Then there's slice, which selects, and this might be even more like the function select, but for rows. So you can say, I just want the first row, and then you could say slice 1. So you can index rows by their integer locations. So to get the first 3 rows, you can say slice 1 to 3. So I've highlighted just the first 3 rows, and that gives you a much smaller tibble of only the first 3 rows. And then you can imagine the cone will have you use arrange and then slice, right? So you arrange by a certain variable, and then slice, so you can get the students with the highest, the 5 students with the highest grade. You would arrange by descending final grade, and then you would slice the first 5. Then finally, we're getting there. 2 more after this, I think. Mutate. Mutate lets you add new variables or change existing ones, and they can be transformations of existing columns. So for example, if you wanted to change final grade, if you wanted to curve everyone's final grade and add 5 points to everyone's final grade, you could say pipe students into mutate and then say final grade equals final grade plus 5. So that's changing an existing column and just adding 5 to all of these numbers. So instead of a 69.4, this first person has a 74.4. So all of these numbers increase by 5. So this is changing an existing variable to make, it's a transformation of an old one too, because it's, So that's mutate. Then you'll do the second cone, and then finally the last cone is about the last 2 functions, which are summarize and group by. Summarize is about creating a summary. It's applying an aggregate function. So taking a big data set and you want to apply some aggregate function to summarize it. So it's going to become a much smaller data set. So going from a big one to a much smaller one, you have to use summarize. And here I have an example of, I want to apply functions like min, max, mean, median, variance, standard deviation, etc., to describe a variable or several variables. You can pipe students into summarize, and what it takes is you need to say a new column name, So I'm going to create these variables grade min, grade mean, grade max. That is, these functions min, mean, and max applied to the variable final grade. And it doesn't all have to be, I guess this is, so what I'm trying to do in this is say, like, what's the distribution of this variable final grade? I could also say, what's the min, mean, and max of grade 1, in the same query. It doesn't all have to be about the same variable. So when you're applying aggregate functions like min, mean, and max, you reach for summarize. And then this is what it'll return. It just takes, well, what's the min of the final grade? And here it's 66, this person. The mean is this, so add all these up, divide by 5, you should get this number. And then the maximum, this person has the highest grade with an 89.7. Then finally, the last function is group by. And if you just run like students and you pipe it into group by with a variable, and you can group by multiple variables too. Here I just have group by one variable, which is sex. So just running these first 2 lines, it'll look like the table hasn't changed at all, but it's added a attribute that's a group's attribute. And then when you do something else, like group by and summarize go really well together. Instead of summarizing the whole data set, it'll summarize the data set by group. So for example, if you want to know the average grade among males and then what's the average grade among females, you would group by sex and then summarize for the mean of the final grade. And then, so the group by part kind of, I think about, it puts all the observations it sorts them into different buckets. So here, sex just takes on male or female. So you have a bucket for males and you have a bucket for females. So group by sorts them into those buckets. And then summarize goes and visits each bucket and says, all right, what's the mean over here? Oh, for females, the average final grade is a 78.6. And then it walks over to the male bucket and it says, all right, what's the final grade over here? Is a 72. And then it reports those, so you can see instead of creating 1 row of summary statistics, it'll create 2 rows, or however many values that this variable that you've grouped by takes on. So the average final grade for females is a 78.6. The average final grade for males is a 72. And that's what grouping by and then summarizing helps you do. So yeah, that's the 7 dplyr functions. Good luck getting through these cones. Please come to office hours if you have any questions. And I will see you next week. Good luck.